Okay, so yesterday we talked about representing and describing transformations, and now we're going to actually get into the specific transformations. We're going to spend today talking about translations. So in your notebook, we are on page 20. Page 20 and 21 are 2.1 translations. You know what? Let me make this full screen. Very sorry it wasn't. There you go. Page 20 is 2.1 translations. Page 21 is also 2.1 translations. I like to label them both at the same time so I don't forget to label them. Okay, so we're going to go ahead and write the definition of a translation, and then we're going to take some of the notes that you should have print off on that foldable there. If you don't have the foldable, you're just going to write it down. You're going to need graph paper. So a translation slides all points of a figure the same distance in the same direction. And I want you to highlight translation. So translation, you're just moving points. Every time I start these videos, I forget to have my highlighters out. Okay, translation slides all points of a figure the same distance in the same direction. All right, you have certain pieces. Find my scissors here. That you either print it out or you will be grabbing a piece of graph paper. If you don't have graph paper, start making a grid on here. Okay. So I've got this piece cut out. I'm going to fold it so that these match up, which is kind of difficult to do, but fold it right there and then right here so that it does this. Woo! Okay, cut that out. And then cut out these 3 boxes down here all separate. So you got 3 little boxes, got them all separate. If you're at home and needing graphs, wait, we will graph them in separate places. So just pause, take a minute. Cut them out. All right, the rest of this will come from your book. So if you are at home and you don't have the graphs, that's fine. Remember, you're just going to get a piece of graph paper or draw graphs in your notebook. All right, I'm going to glue this right here. But I don't want to glue this half because I want it to move in and out. Okay. Then just to go ahead and graph, to go ahead and know what your notebook's going to completely be set up like, got that right there. This is all on page 20. We're not doing 21 yet. You're going to glue this in here, which means if you're at home drawing one, you need to draw a graph there, here, and there. So go ahead and glue all 3 of those in. Or go ahead and draw 3 graphs. Okay, so you got 3 things glued in, and we're going to talk about translation. All right, as I said, a translation slides all points of figure the same distance in the same direction. So we're going to talk about a translation right here. We're going to go ahead and write down points A, B, C, and D from this picture, then we will talk about how they moved in this picture. So, point A, it's hard to read this graph, and I'm sorry. -1, -2, -3, -4, and then 1, 2, 3, 4. So -4, +4. B, -2, +4. C, 1, 2, 3, 4, 5, -5, +1. D, -1, +1. All right, and this, in case you were curious, is right here. So this is actually, the second quadrant there. A prime. Remember we talked about that yesterday? Prime, this is the pre-image. This is the image. Okay. A prime is 1, -1. B prime is 1, 2, 3, -1. C prime is 0, -1, 2, 3, 4. D prime, I forgot to actually write that it is 1, -1, 1. D prime is 1, 2, 3, 4, 1, 2, 3, 4, 4, -4. All right, we're going to close this. Here's what we're doing. I want you to write a description of the transformation and a rule, and you have to know the difference. You have to be able, if it asks you to write a rule, you have to understand what a rule is. If it asks you to write a description, you have to understand what a description is. You have to know the difference because you need to answer it the right way. If you don't answer it the right way, you're going to lose points. All right, a description is literally describing what's happening. So it's definitely a translation. Let's figure out what happened. Let's go from C to C prime just because. I'm going to go left 1, 2, 3, 4, 5. I went left 5. A translation. Left 5. Y'all, here we go again. That is right. I evidently don't know left from right. And leave it to me to not have any whiteout right here. I'll be back. Right 5 units. And it's going to be down. Okay. 1, 2, 3, 4, 5. And down 5 units. That is my description. Let's write the rule. To go right 5 units, we are going to take x and we are going to add 5. And in case you're wondering, well, does that really work? We could check it. Okay, -4 plus 5 is +1. That's probably right. You could check it for all of them. That is correct. Just to make sure. All right, then comma, y down 5 is -5. Here's your description. Here's your rule. You need to know the difference and be able to use them. Okay, we're going to do some more examples. Okay, so sometimes you have to look at a graph and describe it. Sometimes you have to write the rule. Sometimes you're given something and you have to translate. So we're going to translate. Then sometimes you're given a rule and you have to translate. Remember, this is a description. This is a rule. This says describe. That's what you need to start noticing, is what it's actually telling you. So let's take this description and actually do it. So E, I have to move it left 1, 2 units, and up 3. 1, 2, 3. I'm going to mark that E prime. G, 1, 2, and up 1, 2, 3. G prime. F, left 1, 2, and up 1, 2, 3. F, let me make sure I did that right. Over 1, 2, and up 1, 2, 3. It's right here. F prime. Okay. Take your straight edge. Take your straight edge and connect. You need to make sure you're labeling them E and G and F prime. In geometry, if you do not label things, it's not right. That's the whole point. You need to be labeling stuff. Okay. I want you to get in the habit of shading the final answer, which is this picture. Shade it. Obviously, if it's in pencil, that's fine. Shade the answer, though. And label the answer. Label and shade. Okay. Let's do it with the rule. By the way, it's good anytime throughout this to pause these and try them on your own. The rule says x plus 3. That means right 3. 1, 2, 3. Minus 4, so that means down 4. 1, 2, 3, 4. That's J prime. K prime. We're going to go right 1, 2, 3. Down 1, 2, 3, 4. K prime. H prime, right 1, 2, 3. Down 1, 2, 3, 4. H prime. Connect with a straight edge. I gotta find my little straight edge because I don't love this one. And shade in the figure, that image. Remember, this is a pre-image, this is the image. Okay. All right, next we're going to describe the transformation. We are going to describe it right here because we are going to write some tips over here. Okay, so we're describing it right here. What is going on? Now, here's what you need to know. I'm talking about from LMN to L prime, M prime, N prime. Okay, from the pre-image to the image. From L to L prime, let's count that one. I went right 1, 2, 3, 4, 5, 6. Okay. Translation. I know you're going, why do I need to write translation? This whole thing is over translation. I know, but when we get to all of them together, you will need to identify what type, so you need to be writing translation. 6 units to the right, and 1, 2, 3, 4, 5, and 5 units down. Okay, now we're going to write some tips over here. Okay, a shape that slides left means that in your rule, you are going to subtract from x. A shape that slides right means you're going to add 2x. A shape that slides up means you will add 2y. And a shape that slides down means you will subtract from y. Okay. All right, there's another way to translate. We've got the description, we've got the rule. We now have something called a vector. If I were you, I would take a minute and go to YouTube and look up, actually, I'll post it underneath this video. There is a, in Despicable Me, there's a part where, if you remember Vector, he describes his name, that he commits crimes with direction and magnitude. Well, he's telling you what the definition of a vector is, and we're going to use that. So pause this video and go watch that video. Page 21. A vector is a quantity that has both direction and magnitude. So here's a vector. Looks like a ray, but it's not a ray. V with a little vector symbol over it. A vector symbol is like a arrow, but only the top part has the arrow piece. Where you have E, which is an initial point, and F, which is a terminal point. If you are in physics, you should be talking about vectors. If you haven't now, you will soon. That's why it's a good idea to take physics with this class, but I can't fix that for you now. Okay, now, real quick, you don't have to write these pages down, but I'm going to so that you can make sure you tear out the right ones. Tear out page 65 and 67 from your notebook. From your textbook. Tear out 65 and 67 from your textbook. Remember, if I go too fast, you have the ability to pause. 65 and 67. From 65, you're going to cut out example A, you don't need most of it. You literally need the graph. You need example 1. You can glue it in right there. From 67, and 68, you'll need something from the front and back. So from 67, you need 5 and 6. Sorry, there was a long pause there, but they changed the page on me. You need 5 and 6, don't need space. And then from the back, page 68, On page 68, you need letter B and this little sentence right there. So go ahead and glue those in. I'm going to zoom out so you can see everything again. Remember, you can just go back and pause to make sure you got what you needed, which is what's nice about the video instead of live, but you get to choose. My camera's a little funky today. This is not straight. There we go. Okay. Let's go ahead and work on these. So example 1, we're using a vector, and I need to highlight the word vector because it is a definition there that I need. A vector is a quantity that has both direction and magnitude. Magnitude meaning length. Okay. So here is how this works. We're supposed to draw the image of ABC, that means A prime, B prime, C prime, after a translation along the vector B. Well, here's my vector. Here is how this works. It is like slope. We rise 2, we run 1, 2, 3, 4. That's what we're going to do. We're going to take A and go over up 2 and over 1, 2, 3, 4. There's where A prime is. That's how moving with a vector works. B, move up 1, 2, move over 1, 2, 3, 4. B prime. C prime, up 1, 2, over 1, 2, 3, 4. C prime. I'm going to graph with my straight edge because I don't need any mess of a line there. Shade in the image just to make it clear what's going on and what's what. You should label it anyway. But please shade it too. Okay. One more thing you need to learn before we just start doing examples, and you're going to do most of them on your own, is that we need to relate rules and vectors. Using the rule, x comma y maps to x plus a comma y plus b, or just x and y are just number letters, so it's hard to see this. I should say x plus a, I made a mistake there, is the same as moving along the vector a comma b. And that's almost like less than signs, but it's not. This is called component form. I usually put that on the notebook test. When I say, what is component form? Your answer for what is component form is this. So highlight that and box it in so you'll know what component form is on your notebook test. All right, we're going to use that for number 5 and 6. This is component form. It says draw the pre-image and image of each triangle under a translation along -4, 1. Based on component form, that means left 4, up 1. That's what component form and that actually means. So we are going to start by graphing the image, the pre-image, and then we'll graph the image. Go ahead and graph 2, 4, 1, 2, 4, 2. I'm not shading this one in because this is the pre-image. I don't want you to shade that one. I want you to shade the final solution. Left 4. up 1, left 4, up 1, left 4, up 1. I want you to pause the video and do the same thing with the number 6. And I'm going to keep going. But you pause the video and do number 6. Same vector. 2, negative 1, 2, negative 3, 4, negative 3. I always do that where I put the letters in the wrong place so that they are in the figure, but oh well, I'll do better on the next piece. Alright, left 4. 1, 2, 3, 4, up 1. P prime. Left 2. No, left 4. 1, 2, 3, 4, up 1. Q prime. Left 4. 1, 2, 3, 4, up 1. R prime. Okay. So there are 3 ways to translate a vector. You can, to do a translation. You either doing it by the description, you were doing it by the rule, or you're using a vector. You have to be able to do all 3. Last, letter B. It says, well, you don't know what it says. We are going to write the vector in component form. That means we need to actually find out how this is moving. So we're going to find out, let's go from A to A prime. How many units do we go up? 1, 2, 3. How many do we go left? 1, 2, 3, 4, 5. I did it again. We went right 5. Okay, here's what you need to know. I'm using my tips over here to the left. It says that if the shape slides up, we add the y. So in the y coordinate, we're going to put a 3. Positive 3 because we went up. Okay, using my tips over here. The shape slides right, we add, it's going to be positive, to x. So x is 5. There is component form. If it was in a rule, even though it doesn't say to do a rule, the rule would be x plus 5, y plus 3. That lets you know how I get both of those together. Okay. Your homework is in your book tonight, so go ahead and start on that. Remember, you can't have late work in geometry, which means if you don't have a way to upload it, you're bringing it to class tomorrow finished so I can see it and check it off. I'll see you tomorrow.